Hello everyone, I'm Sheiny Almeida. The title of my poster is Routability Driven Detailed Placement Using Reinforcement Learning. The goal of my research is to develop a reinforcement learning framework to improve circuit routability in detailed placement step before the routing. So here are some of examples of the current challenges of the VLSI routing. What is important is to notice that many detail routers strongly rely on processing to attain those design rules. So I want to reduce the computational effort of routing step but in placement step before the routing by improving the routability of the placement solution. The advantages of using reinforcement learning is that the training data is generated on the fly and also the agent learns creative solutions because it's not trying to replicate the results of a specific tool. It's actually learning how to solve the problem. Here are the proposed workflow. Once trained, the reinforcement learning model will decide which detailed placement algorithm it should apply to improve routability. To identify the regions that I have to apply my technique, I'm going to use a routing predictor to predict from placement features, for instance pin density, cell density, macros, width and height of the cells, neighbor nodes, and so on. I'm going to predict where are the regions of the placement that I have to apply my technique that are prone to have routability problems. So here are the details of how I'm going to do a training episode of reinforcement learning. It receives at a state representation the predicted node on the center with its neighbor bins. The state is part of the grid, as I said. The reward will be the wire length change in the signal determined by the legalization and the routing predictor. The stop criteria initially can be a fixed number of iterations or when there is no predicted routing violations. And also when the technique adds new violations, I will have to undo that movement because I want to reduce the number of routing violations, not add new ones. And I think that's it. Thank you for your attention.